Okay, this is the fifth video for the semester review. It'll be covering problems 41 through 50. So the first one, given the following data, which of the following is the box plot and whisker graph for this data? So basically, I need to go ahead and input this data in the calculator. Just as a reminder, turn the calculator on, press Stat Edit, and then type the data in 10, 8, 9, 16, etc. in the stat edit, which I've already done to speed things up. Then I go second stat plot, make sure my stat plot is on. So I arrow to the left, press the left arrow, make sure it's on. If it's on, I drop down and I select the one with, I have two box plots there. I select the one that has little dots or shows the outliers. I press enter. Now, I only have one list, which is X1, or my X list should be an L1, so I press second, followed by the number 1. And my frequency is just 1. And at that point, I should be able to press zoom 9. And of course, if I get an error like that, I need to check to see if all my stat plots are off. So second quit. Off, so that's good. So it must be in Y equals. So I go to Y equals. And sure enough, I have something in Y equals. I press clear and get that out. Then I go back to second stat plot. So it looks good. Zoom 9. So zoom 9 should give me the graph. Well, it's nice that I have the graph, but I can't tell anything about it. So I use the trace feature. And I can arrow back. And it says my minimum on the trace feature says it should be at 8. Well, that could be just about any of those. All right, just about any of these have a minimum at 8. The next feature should be at 10. And that's at 10, that's at 10, that's at 10, and that's at 10. And I have a median at 16. Well, this median could be at 16. Looks a little high. That looks good, that looks good. A Q3 at 20. This is definitely at 20. This is not at 20. That's more than 20. This is at 20. And a 22. Well, the only one that was precisely right on all of these, and you have to look fairly closely, is letter C. All right. I will say this, you have to look very, very carefully at these. Otherwise, it's hard to tell which one it might be. But the correct answer is letter C for this particular one. All right, and I guess I should point out the reason B is wrong is this one is it right at 10? And if I look closely at this one, it's over 10, it's at 11. So look at these very, very carefully. They're a little bit close, but make sure you line them up. Once again, Q1, or the minimum, Q1, the median, Q3, and the max. Had you preferred, you could have gone stat, calc, one variable statistics. Once again, our frequency. And we see that we have a minimum at 8. Q1 is at 10. The median is at 16. Q3 is at 20. And the maximum is at 22. All right. Okay, so the next one, problem 42. Problem 42 is a lot of work. I'm going to have to enter I need to know which data set makes that box plot. So I have to enter a data set, test it out, enter another data set, etc. Keep entering data sets until I find out which one is actually that one. I'm going to pause while I enter the first data set. So real quickly to catch you up to speed, I went stat, I pressed the stat button, made sure edit was highlighted. So the stat button, edit's highlighted, press enter. I have my data entered, 3, 10, 11, 13, and 21. Then I went stat, calc, one variable statistics, L1, frequency, I don't need anything. And when I do that, I end up getting min of 3, a small value of 3. And by the way, you're probably asking yourself, why didn't he do the graph? Well, since I was going to have to check to see if this is 3, Q1 right here has to be 9, the median has to be 12, Q3 has to be 18, and the max has to be 21. I thought it'd be easier just to go to stat calc, and I have the minimum at 3, so that checks out. Q1 that was supposed to be at 6 is 6.5, and right here we have 9, so it can't be letter A. So I'm going to go ahead and go back to stat edit, and I'm going to right arrow up, press clear, that empties that out. I go 3, enter 6, enter 9, enter 1, 2, enter 15, enter 18, enter, and 21. Stat calc, one variable statistics, L1, and I have 3, 6. So min at 3, that works, but I have a 6 for Q1 and I needed the 9, so it can't be B. So I head over to C. And once again, stat, edit, clear. I just arrowed up to the top and pressed clear to get rid of the values. 3, enter, 9, enter, 10, enter, 12, enter, 16, enter, 18, enter, 21, enter. Stat, calc, one var stats, second one, that's L1. Leave that blank. And this time I get a minimum of 3, Q1 of 9, so we're matching there. A median at 12, that's good. Q3 is at 18, and the maximum is at 21. So that one matched up perfectly. So letter C is my answer for that problem. Number 43, an outlier problem. The number of hurricanes reaching the east coast of the United States was recorded for each of the last 10 decades by National Hurricane Center. Summary measures are shown below. Which of the following is true? And basically, I already read these problems before, so I know it's looking for outliers. So I need to calculate my IQR, and IQR is just Q3 minus Q1, which in this case is 18 minus 15. So 18 minus 15 equals 3. So my IQR equals 3. Now, to check for outliers, I need to find my fences. So if X is smaller than, and this is a formula, if X is less than Q1 minus 1.5 IQR. All right, well, Q1 is the lower quartile, is 15. So 15 minus 1.5 times 3. And that 3 came from the value we just calculated. I know that doesn't look much like a 3, but it's supposed to be a 3. Let's do that. 15 minus 1.5 times 3, and I end up getting 10.5. So if we have a value less than 10.5, it's an outlier. Well, what is our smallest value? 12. So we have no outliers on the low side. So no outliers on the low side because 12 is above it. We would need any value less than 10.5 would have been an outlier on the low side. So now we need to check the high side. X has to be greater than Q3 plus 1.5 IQR. Q3 is the upper quartile, which is 18. 18 plus 1.5 times 3. All right. So 18 plus 1.5 times 3 gives me 22.5. So if I have any X value greater than 22.5, I have an outlier. Well, I have a max value of 24. So we know for sure 24 is an outlier. okay? But because these are box plots, we don't know if we have any data that are between 22.5 and 24. So we know we have an outlier on the upper side. So basically, 24 is an outlier, and it's possible that there are some outliers at the high end of the data set, okay? So it's possible that there are other outliers up there because there could be values between 22.5 and 24. We just don't know, all right? But we do know that there are no outliers on the low end of the data set. So our answer to this, to 43, is letter C. Okay, a graph not shown of the selling prices of homes in a certain city for the month of April. And this is number 44. So once again, a graph not shown of the selling prices of homes in a certain city for the month of April reveals as the distribution is skewed to the left. That means it was stretched to the left. So it's going to look something like this. All right, it's been stretched to the left. And one thing we know is if the median were here, the mean is over here. So therefore the mean is less than the median, all right? And the mean is less than the median. You're like, well, how did you know this? I said, this is basically a number line here. So if this is 0, 1, 2, 3, 4, 5, 6, it's like, oh, if we had a median of 5, the mean could be 4. But basically we don't know exactly what it is. We just know that because it's stretched to the left, the mean is less than the median. Number 45. Oh, so that's so for 44, that's our answer. For 45, the median of any data set is always represents, well, the median is the middlemost number. So it's half of the, it's halfway in the data. It's the middle number, which means it's the 50th percentile. 50% of the data is larger, 50% is smaller. All right, so it's the 50th percentile. Given that, this is number 46, given that the probability of E equals 0.32, the probability of F is 0.15, and the probability of the intersection is 0.048, which of the following is a correct conclusion? E and F are both independent and mutually exclusive. Well, remember, to be mutually exclusive, we can't have an intersection. And here they're telling us the intersection is there. So anything that says mutually exclusive is wrong, okay? We know it's not mutually exclusive. If they're independent, and they could be independent, but we need to check it out. If they're independent, I should be able to multiply these two and equal this, all right? Because the independence rule is the probability of A times the probability of B equals the probability of the intersection. So I'm going to take 0.32 and multiply it by 0.15. 0.32 times 0.15. When I do that, I get 0.048, and that equals the intersection. So in this case, they are definitely independent. So this says neither independent, so this is wrong. The events E and F are mutually exclusive but not independent. It's like, no, we know they're not mutually exclusive. The events E and F are independent, that's true, but not mutually exclusive. That's also true. Letter D, the events E and F are independent but not mutually exclusive. Terry waitress, this is number 47. Terry waitresses 10 days out of the last 2 weeks. The amount of money she earned each day in tips are 32, 58, 17, 27, 69, 73, 42, 38, 24, and 52. How much money is at the 50th percentile? In this case, they're asking for the median. So if I were to put those numbers in order from smallest to largest and find the middle one, that would be my answer. A quicker way in this case would just go to stat edit. I got to make sure I don't make a data error inputting this. But if I go to stat edit and input the data, 32, 58, 17, 27, 69, 73, 42, 38, 24, and 52. All right, so I've input the data. Once I've done that, I go to stat. Oops, wrong button. I go second quit, clear that out, stat, calc, one variable statistics. This is O1. And I scroll down until I find my median value. And I find a median value of 40, which is letter D. All right, my median value here is 40. There's my Q1, etc. All right, number 48. A police car is using a radar device to check motorist speeds. Prior to beginning the speed check, the officer estimates that 40% of motorists will be traveling more than 5 miles over the speed limit. Assuming that the police officer's estimate is correct, what's the probability that among 4 randomly selected motorists, the officer will find at least one? We have a couple things. We have a fixed probability of 40%. We have a fixed number of trials of 4, and we have an at least phrase. So with this case, anytime we have it at least, we know we're going to be working with a 1 minus. The fact that we have a fixed number of trials tells me we're working with a binomial. And anytime they say at least with a fixed number of trials, this makes it a binomial CDF. And in this case, my trials happens to be 4. My probability is 0.40. This is what's really important, is to make the number line. So assuming the police officer estimate was probability that among 4, so that means up to 4, at least 1. So this is what I'm looking for. If the officer has 1 speeder, 2 speeders, 3 speeders, or 4 speeder, the officer's estimate is correct. So what I don't want, I always subtract out what I don't want. You go, why didn't you subtract out 1? Because it said at least 1. He wanted 1. So we don't take away what we want, we keep what we want and subtract out what we don't want. Now you're maybe wondering to yourself, how did I memorize this? Well, I've done it so many times, but the calculator will actually walk you through it. So here we go. You have to remember, at least is going to be 1 minus. So 1 minus second vars. I'm going to scroll down to binomial CDF. And sure enough, it asked me for trials. Our trials were the 4 cars. The probability of speeding is 0.4. The X value in this case is what we're subtracting, which is 0. And I end up getting 0.8704, which in this case happens to be letter D. Janae's first 7 French grades, this is number 49, for the year are 91, 87, 80, 99, 85, 78, and 90. What is the grade at the 75th percentile? So basically, we're looking for the 75th percentile, happens to be Q3. And I could either do this by making a box plot or just going stat edit and doing a stat calc. I'm going to do that version. I think it's much easier to read. So arrow up, clear that out, enter the data, 91, enter, 87, enter, 80, enter, 99, enter, 85, enter, 78, enter, and 90, enter. And make sure I have 7. I do have 7. Stat, calc, 1 variable statistics, L1, leave the frequency blank, and I need to scroll down until I get to Q3. There's Q3, which says 91, all right? So in this case, for number 49, my answer is D, all right? So for 49, it's 91. If the probability of A equals 0.2 and the probability of B equals 0.1, what is the probability if A and B are independent? Okay, so if they're independent, we need to remember this. The probability of A and B equals the probability of A times the probability of B. So we need to remember that part. That's going to be really important. And let's go ahead and, well, we'll come back to that. They also gave us one other thing, the probability of A union B. The probability of A union B has this formula right here. That equals the probability of A plus the probability of B minus the probability of A and B. Well, we know the probability of A is 0.2. We know the probability of B is 0.1. But right now, we don't know A and B. But they told us they were independent. And if they're independent, A and B has this formula. Oh, we know A and we know B. So A happens to be 0.1. B happens to be 0.2. So when I go to the calculator and I go 0.1 times 0.2, I end up getting 0.02. So the probability of A and B equals 0.02. So I need to subtract 0.02. So 0.2 plus 0.1 minus 0.02 equals 0.28, and we get our answer, which is letter B. I'm going to go ahead and do 51, even though I didn't address that earlier, just because it ties very similarly to the one above. Probability of A equals 0.2. The probability of B is 0.1. What is A union B if A and B are mutually exclusive? Remember, mutually exclusive means they have no overlap. Okay, we'll come back to that part right here. A mutually exclusive, no overlap means the intersection has to be 0. A union B from the problem above tells us the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Well, they just told us A was 0.2, B is 0.1, but we have no intersection, and we know that because it's mutually exclusive, so the intersection happens to be 0. So 0.2 plus 0.1 is just 0.30. So our answer is 0.30. In this case, that shows up as letter C. All right, that's the end of the 5th video.